Good morning, my name is Brian Perry. I'm with the Concrete Institute in Midrand. I'm a professional engineer and my current position here is Managing Director. I also am the Vice President of the International Society for Concrete Pavements.
Thank you, Brian. We'll start by asking this morning, why do you believe concrete roads are sustainable?
Well, I think worldwide sustainability is important. People have always generally only looked at economic benefits, whereas looking at true sustainability is looking at both the economic, the environmental and the social. And I think more and more emphasis is now being put on the environmental and the social aspects. So, exactly the same with roads. Whatever type of road, sustainability issues are becoming more and more prevalent, and a lot of codes of practice and design codes are requiring that you look at all the aspects of sustainability.
And perhaps you could expand on the economics of sustainability. How is this being measured now?
Well, in terms of economic, looking more at the economic side is very much on cost, looking at life cycle analysis, taking into account the length, the life of the pavement. Traditionally, we've always really looked at the initial cost of building the pavement and not worried too much about the maintenance and recycling, because that happens much further down the line. But more and more clients are now starting to look at what is the total cost of an asset, whether it's a road or a structure, over the full lifespan of the road, taking into account the initial construction, the maintenance, the recycling at the end. And more importantly, with pavements, is often the biggest environmental impact is the vehicles using the roads. Right. So that becomes important in terms of ease of use and things like that. So all of those need to be taken into account.
Great. So if we can just turn to the next question, why do you believe that concrete roads are sustainable?
Well, I think there's a number of issues. There's obviously the social and economic ones. The ones I'd like to highlight initially are the environmental ones. Concrete generally has relatively low CO2 emissions. There are also other benefits from it. It's labor intensive, it can be built labor intensively. That's not necessarily the case overseas. In South Africa, we're building freeways using labor intensive methods, which adds to that. It's a locally available material. The cement, the aggregate, everything is local. There's also recyclability. Concrete is eminently recyclable. One can, at the end of the period of time, use it. One that is not often talked about is the fact that concrete pavements are very light coloured, so we have very high reflectance, and that has two benefits. The one, in terms of lighting of streets and roads, is that you can get away, because of the light surface, you can get away with far less lighting, less powerful lights, or one can increase the spacing, so there's an energy saving there. And the other one is the heat island effect. Obviously, dark pavements, structures absorb heat, whereas concrete reflects. And there's been some studies done in the United States that show that you can have significant reduction in the air conditioning costs of structures surrounding light-coloured pavements. So there's those benefits as well. We also can look at, in terms of permeable pavements, there's a big move these days, either in the interlocking block type pavement or just pouring permeable concrete. In that, one can harvest the water so that it doesn't run off into stormwater drains. One can harvest it in the pavements and reuse it. And then also, there's been some moves in Europe to try and make concrete, use concrete as a pollution control tool, whereby using titanium dioxide in the concrete pavements, it can actually absorb noxious gases and convert them into non-noxious gases. And there's been some quite interesting studies in Paris, where they've done a whole street, the pavement, the sidewalks, everything with this treated concrete, and it significantly reduced the pollution levels in the atmosphere in that particular environment. So there are a large number of those factors that make concrete environmentally sustainable.
And building on the sustainability topic, what are the CO2 emissions from concrete? As an aside, it's stated currently the emissions from the production of cement are about 5% globally. So
internationally, yeah. People often harp on the fact that cement is a large polluter in terms of that, and that's because of the way cement is made. Obviously, we convert calcium carbonate into calcium oxide, which drives off the CO2. And to do that, you have to heat it. So there's two sources of that CO2 emissions. And as you stated correctly, internationally, it's about 5%. In South Africa, the proportion of cement is a lot lower. But that's not because the cement companies here are any better. It's because we have Eskom and Sasol, who are large polluters. So the proportion in South Africa is a little bit lower. However, we don't build roads and structures using cement. We use concrete. And although cement, the sort of stated figures are about 1 ton of CO2 per ton of cement made. Depending on the type of cement you use, these days we're putting a lot more extenders into cement, fly ash, slag, things like that. One can get that down to about half of that, to about half a ton of CO2 per ton of cement. We then make concrete out of that, where we add aggregate, which has very low CO2 emission or CO2 equivalent. We add fly ash, we add slag, we add water and add mixtures. And generally one can get the CO2 emissions per ton of concrete down to between 100 and 150 kilograms per ton, which is significantly lower than the 5% that everyone talks about. And we don't actually build with cement. So the numbers are much, much lower when we talk about the CO2 equivalent emissions from concrete.
Excellent, thank you. You touched earlier on the social benefits of concrete roads, and you defined sustainability in a broader sense. How are concrete roads benefiting communities in South Africa, including emerging communities?
Okay, well, I think the one point that I did mention is they can be built labor intensively, so it's a job creation. And generally one needs a lot more people building a concrete road. So there's that thing. The concrete roads generally perform over very long periods with relatively little maintenance. And we have some examples of that. The first concrete freeway built in South Africa was built in the late 60s. That had an asphalt overlay in the 80s, but it is still the same pavement. There's been very little done to it. That's the N2 in the Cape. So they have very long life and reduced maintenance. And obviously reduced maintenance means less traffic jams, less those sorts of things, pollution, time wasting and things like that. The other economic, and obviously the life cycle analysis one needs to look at. And when you compare pavements, unfortunately concrete generally costs a little bit more to build initially, looking at a comparative with other types of pavement types. So it's generally a little bit more expensive initially, but a large number of studies have actually shown that over a long period of time, concrete is actually cheaper over the life cycle. Unfortunately in South Africa, one of the problems we have is a short-term focus. Local authorities, provinces are all worried about how many kilometers of road they can get per rand now, and the maintenance issues are someone else's problem down the line. So that's one of the problems. And there's been quite a lot of research, and we have a publication on the sustainability of concrete roads. And there was some work done in France where they looked at a whole lot of sustainability issues in terms of emissions, in terms of toxicity and things like that. And they showed there that concrete is actually far better economically and from an emission point of view than asphalt pavements. And there's also been some very interesting studies around the world, in the UK, Japan, Sweden and the United States, that have actually shown between 2 and 4% fuel saving of heavy trucks using concrete pavements. So generally, there's a large fuel saving in terms of that.
And if we look at road design and safety, does that have implications for concrete? Well, we can design the concrete road. In terms of safety issues, it's around skid resistance, draining, and there's a large number of textures one can put onto the surface of concrete pavements, where one can use it for skid resistance, or for noise reduction. So there are a number of techniques. We haven't used all of them in South Africa. Traditionally, we've always had a textured time transverse texture, which unfortunately is quite noisy. But there have been a lot of developments in terms of exposed aggregate finishes in Europe, where they can be as quiet as any asphalt pavement. So from the noise point of view, that's fine. Generally, the quieter you make it, often you lose out on the skid resistance side, so from the safety point of view. But yeah, one can tailor the surface finish to try and result in a relatively low noise pavement, but still having adequate skid resistance. Excellent. And are concrete roads becoming popular in city centres. I see the trend in intersections, for example.
Yes.
Not just concrete block paving, but sometimes concrete
as well.
in situ slabs.
In the urban environment, where it is coming into quite a lot is with these new bus BRT type routes in Johannesburg, in Pretoria, in Tembisa, Kuruleni. And obviously those are heavily trafficked with the buses, so they lend themselves to more heavily trafficked roads. One of the downsides with a concrete pavement in a city or urban environment is the services issue. And you can build in all the service, the ducts and that you want, but when a utility needs to go across the road, they just dig a trench across it. And then, unfortunately, concrete is a bit more difficult to repair properly. Block pavements is a lot less so, and that's, I think, why you're seeing a lot more of the block pavements going in intersections. There's also a safety issue with the block pavements, is that, and they don't just do the intersection, they do a short run up into it, and that change in noise, the change in texture, also alerts the driver to the fact that, hey, wait, something's changing. So there's a safety aspect to doing that as well. I think the in urban environments, in freeways, again, it comes down to whether you're looking at the long-term view or the short-term view as to whether you would build a concrete pavement or not. The toll roads, obviously, they try and limit their upfront cost as much as possible and then spend the money down the line, because that's when they get the revenue, so it doesn't lend itself to building a more expensive pavement up front.
Okay. And just another question. Sometimes you see concrete roads which have now been overlain with asphalt. What's the motivation for that?
Well, there's a couple of reasons. The two that are obvious, the Cape Road that I mentioned, that was unfortunately the first major structure in South Africa that suffered from alkali silica reaction, which is where the alkalis in the cement react with the aggregates. And it's an expansive reaction and it created problems. So there the asphalt was put over the top to prevent water ingress, because you need water for the reaction to happen, and to address the riding quality because of the problems with alkali silica. So that was put down in the mid-80s. The other one is the Ben Schoeman, and that was actually designed to get that. It was designed for a 13-year lifespan, ultimately to get a thin asphalt overlay, which would extend the life by another 8 or 10 years before they'd have to do something else about it. And that was, the Ben Schoeman is a continuously reinforced pavement, so it has cracks at sort of 1 to 3 meter centers. And the intention, when those cracks started getting a little bit wide, put the asphalt over the top to stop the water getting in. There are others as well. When they did the Gauteng Freeway improvement upgrades, obviously some of the problems there was where they were widening the roads, and especially the Western Bypass, where some places widened on the inside, some places widened on the outside. And there was also a problem with, it was very difficult to have the white line not following the line between the asphalt and the concrete. So there they decided to put concrete over the asphalt over the whole thing. And parts of that were also for riding quality, noise reduction and things like that. So there's also a trend worldwide to look at, in South Africa, it's always been about whether it should be a concrete pavement or an asphalt pavement. And the Institute's view is that we shouldn't look at it in those terms. We should actually look at the appropriate pavement for the appropriate thing. So we're talking of composite pavements, a combination of asphalt and concrete. And in 3 different ways we can composite it. We can composite it vertically, where we put the concrete down for the main structural elements, so it will last for a long time. You don't have to do any rehabilitation. And we put a thin asphalt on the top for riding quality, skid resistance, and things like that. So, in other words, compositing it vertically in the pavement. We can also composite it horizontally, which has been done on Town Hill on the N3, where when they rehabilitated that road, they rehabilitated the 2 lanes going up the hill in concrete, because that's where the trucks go, and the 1 lane coming down, and the other lanes in asphalt, so doing it horizontally. And the third way, which we haven't really used in South Africa, is that you can composite it longitudinally. So put concrete in the steep grades, which is where the rutting takes place, where the trucks travel slowly, and put the asphalt in the flat areas and things like that. So we're tending to get away from this thing that you have to have a concrete or you have to have an asphalt road, to try and say, well, let's use the best properties of both materials and put them in appropriate applications.
And that flexibility is important. How well covered do you think these topics are at undergraduate and postgraduate level in South Africa? Very
poorly at undergraduate level. I think concrete in general is an issue. There's so much material as an undergraduate civil engineer that you've got to get through in terms of all the materials and all the other topics, structures, hydraulics, geotechs. but very little. At postgrad level, in terms of pavement design, there's quite a lot of work being done mainly at Stellenbosch University and the University of Pretoria. So at postgrad level, there are quite a lot. The institute's involved with University of Stellenbosch. We run a block release for a master's degree every 3 years at Stellenbosch, where these sorts of issues. Stellenbosch also very involved in the asphalt business as well. They're really the premier pavement institution in South Africa. And so at postgraduate level, if you want to get into it, there are a number of courses. The institute itself, we actually run two courses related to concrete pavements, one on design and construction of concrete roads, and the other one on concrete industrial pavements for hard standings, warehouse floors, and things like that. So there is information that one can get. In addition, for the design of concrete roads, we, together with SANRAL, developed a software package called CNC Pave, which allows you to design concrete pavements, primarily roads, not that much on industrial pavements, although we're busy trying to convert it to that. It's a web-based program. It's available from the Institute, and SANRAL has now incorporated that in their pavement design method, along with the others. So effectively, if a consultant's now doing a job for SANRAL, they need to look at all the different pavement types and justify why they've made a particular choice. So more and more, it's becoming that you've got to look at all the options rather than just the one that you favour up front.
And when we talk about concrete roads in South Africa, currently what is the percentage in terms of national routes, and where do you think the future outlook is for concrete?
Nationally, very, very small. It's probably less than 1 or 2%. And that's really on the heavily trafficked freeways. The outlook, SANRAL I know are very cognizant, and they make sure that they look at the right options. And sometimes there are just options that concrete, because it generally is quite thick, they have options with drop-off, whereas asphalt you can put it in thin layers, so transferring traffic, and that's not an issue. So sometimes those are issues that they also have to take into account practical. But they would like to use concrete roads, and they do use them. You can see that where they're building them at the moment. And we see the other big market is for the BRT type systems. It's interesting, in Cape Town, the BRT, the concrete is done between intersections, and they put asphalt in the intersections or blocks just because of the services issue. Where we see a big market is low volume roads in townships, township street upgrades, and things like that. And there's been a development, CSIR have been driving it using what they call ultra thin concrete, which is a very thin 50 millimeter concrete, 30 MPa with a light mesh. And that can be put down in township streets, and that relatively cost effectively, where there's very little traffic. There's maybe one refuse truck a week or something like that. Those pavements can all be designed within CNC Pave. It covers for that whole range of pavements from the very low volume up. And we would see that the low volume ones as a very good example of the sustainability. You can create jobs, you can teach people how to maintain them and things like that. So it's changing a mindset. South Africa has traditionally been a flexible asphalt type pavement, and trying to change that mindset from what people are comfortable with is quite difficult.
So from that we can understand that the public sector environment is viewing the future of concrete in a far more proactive light. But how does that compare with other international countries?
It varies. In South Africa, we're trying to persuade the local authorities, provincial authorities. I think SANRAL has bought into it. Some provincial authorities have built, KZN has built some concrete freeways, Gauteng has built some concrete roads. And then down at a municipal level, it's really trying to get in there. The problem is most of the municipalities don't have any money to fix the roads anyway. But where they are starting to use concrete in low volume. It varies around the world. If you take a country like Brussels, all their freeways are concrete. They took that decision. If you look at the United States, it varies from state to state. You can have one state right next to another one. One is all their pavements are concrete, the adjacent one all asphalt. It depends on who the chief engineer is and where their expertise has been, where the research has been. So it varies all around the world. The interstate system, when it was built in the United States, was about 50-50 between concrete and asphalt. That's changed now with rehabilitations and things like that. So it varies all over the world.
Okay, thank you, Brian. Now, if we could move on to talk about floors as part of our pavement discussion. In the current scenario, apparently concrete industrial floor problems account for in excess of 80% of the problems that the Institute is asked to investigate and report on. It seems like a very high number. Why is this the case?
Yes, it is. And it's always been like that. I've been with the Institute some 30 years, and it's always been that concrete floors, pavements have created a lot of problem. I think there's a number of reasons for it. I think primarily, often the industrial, the warehouse floor, or the external hard standing at a factory is often detailed or designed by the structural engineer. And a floor on the ground is a pavement rather than a structure. They perform differently, they need to be detailed differently, and sometimes that point is missed. When we run our course on industrial floors, concrete industrial floors, I always ask all the people who are structural engineers, ask them to put up their hands and then tell them they must forget everything they know about structural reinforced concrete and start from scratch with a floor on the ground. So I think it's partly that. I think partly inadequate detailing and specification. We don't have an SABS specification specifically for industrial floors. So generally the normal structural one gets used and it doesn't have all the right clauses and requirements in it that you would need for a floor on the ground. I think often there's split responsibility on site where you often have the client, the engineer, the contractor, a subcontractor, a ready-mix supplier, often all at loggerheads rather than all working in the same thing, where there's split responsibility, who's responsible for the earthworks, who's responsible for the concrete levels and things like that. I think often a lot of skills and knowledge, people assume that if you're pouring concrete on the ground, what can go wrong? It can't fall down, it can't go anywhere. And I think there's no barrier to entry. Anyone can buy a bucky and a power float and become a flooring contractor. And I think what amazes me is just how few people actually who are either designing using concrete as a material or building using concrete as a material who don't understand the fundamental basics of the material and how it behaves. And I mean, we run a whole range of concrete technology training courses to try and address that need, and still the problems are there. And I think also people don't understand basic construction techniques. There's a lot of problems. People out there who don't understand the timing of floating or troweling when you have to cut joints and things like that. So it's all of those sorts of things that result in these sorts of problems.
Which is a big concern when it borders on negligent design. What is being done to reduce these incidences?
Well, at the Institute, for the last 30 years, have been running a course on design and construction of industrial floors. We actually battled to run it. The last couple of years, there's been relatively few takers. We're also in the process of trying to develop an SABS specification in the new SANS 2001 CC series, which are the concrete series, and trying to have a document specifically for industrial floors on the ground, which will hopefully address the specification side of it. Yeah, I'm not sure. And some of the feedback we've had is often junior engineers get sent on the course. They get back to the practice and the senior guys say, yeah, that's all well and good. We've been doing it this way for the last 30 years. Continue doing it this way in future. So a lot of the techniques are not there. So there are a number of initiatives that we're trying to do that. The bigger floors now, a lot of the big flooring contractors are tied to international companies, and they often do the design and detailing themselves. So they offer a whole turnkey project. They will do the design, they'll do the construction, and they'll offer a warranty. So that is reducing some of the problems on the big warehouses, but on the small stuff, it's still a problem. It's often a structural engineer. He then goes to a normal building contractor to do the floor, whereas floors are a specialized application. One should use a specialized contractor to do them.
I mean, South Africa has a very high standard for civil engineering. So I wouldn't be surprised to hear that other countries also have this problem.
Yes, I think there's a lot of problems. I think what's also created more problems is that the requirements for industrial floors, especially internal warehouses, are becoming more and more stringent in terms of level and tolerance control. You know, they're going up now 18 meters with racking systems, what they call very narrow aisles. So the forklift, the operator travels with the forks. So he actually goes up to the 18 meters while he's driving down. And so any irregularities in the floors can create big problems. And there's been a number of cases where the forklift has hooked the racks and the racks have collapsed, people have been killed. So it's becoming more and more high-tech to do that, and that's where these highly specialized companies come in. Obviously, the contractors here don't always read the specification properly, they don't price it properly, and then they don't meet the tolerances, and then it's an issue to try and address it afterwards. So it's becoming very much a more high-tech application. External hard standings, really, that's just bad detailing, bad construction, things like that create the problems.
So clearly it's an issue of constant training and education and re-education.
Right, yeah. In addition to the course that we run, we have a book, Concrete Industrial Floors, which is sort of known as the Bible in South Africa. And that's due to be updated again now. There have been new techniques, new developments in designing, constructing industrial floors on the ground. But yeah, it's just really, and a lot of the reports that we do, we try and use them as a training tool where we write the report. We don't just go into what caused it, we give some background into it, so hopefully whoever ends up with the report doesn't make the same mistakes on the next jobs that they get involved in, whether it's the contractor, the consultant, or even the client.
Is there an area within the discussion we've had that applies uniquely to airports, runways and aprons?
Not really. We don't have any concrete runways in South Africa. And I think, internationally, a lot of airports do have concrete runways. I think it's a lot more difficult for a lot of our airports, we only have one runway. And if you have to do repairs, asphalt repairs are very easy. You can do them in a few hours, mill a bit of asphalt off, put some more on. It's more difficult to do concrete. Aprons are always concrete because of the fuel spillage. So that's a concrete, and that's effectively a large hard standing. The thickness varies. So for airports, hard standings, concretes are about 400 thick. Average industrial warehouse is about 200, 250. And then also container depots where they handle the big shipping containers, and those go up to 450 thick for the vehicles. It's not the containers, it's the vehicles that handle those fully loaded containers. So there are design parameters for those, but there's nothing specific. The same jointing details, the same specification applies whether you're doing an airport apron or whether you're doing a hard standing for a container depot or a hard standing outside a warehouse. The only difference would be in terms of sealing. Obviously in the airport situation, you've got to use sealants that don't get attacked by fuel and oil spills and things like that. But other than that, there's very little. And
we've been talking about South Africa. Does the Concrete Institute also work within the Southern African region?
Yes, we do. We've run a number of training courses in Zambia, in Zimbabwe. We're running training courses in Namibia. So we will tend to work, although we're funded primarily by South African cement producers, but we do operate in terms of consulting and training. We've also done a training course in Nigeria. We're looking at running training courses in East Africa, Kenya, Tanzania and Uganda. And in fact, I'm running a concrete roads course in Lusaka in the next 2 weeks. So we try and offer those outside. The roads training courses we run in conjunction with the South African Road Federation, so it's a joint venture between us. They obviously primarily in the roads field, and so we've sort of tagged onto that.
And just building on that, are donor agencies like the World Bank looking more closely at concrete roads?
We don't really have the donor agencies in South Africa. They don't really play a role here, and we're not really involved in that side of it. I know I've been involved specifically in Zambia with what they call the Road Development Agency, which is the equivalent of SANRAL. And some of the cement and aggregate companies there have been pushing very hard. I've run a number of training courses for the RDA engineers. Also in Kenya, they've built one of the main roads in Nairobi. Bugatti Highway was done in concrete as a result of our interventions. But really we're not marketing it in that sort of thing. If people approach us for input and advice, then we'll go and help them and do it on that.
Thank you, Brian. In summary, what would you like to say to the engineering viewers about the science of concrete and sustainability?
Well, I think if I could say specifically with industrial pavement, concrete pavements, that really there is information available. There are training courses, there are publications. We have a publication on the sustainability of concrete pavements. We have one on construction of concrete roads. We have a design and construction manual for concrete industrial floors. We run 2 training courses specifically on concrete floors and concrete roads. And really, there's no excuse for the sort of problems we're seeing out there. The information is available. The Institute also offers a free advisory service. Anyone can phone in at any time and get free telephonic advice on any aspect of cement and concrete. So really, come and talk to us before you build your concrete pavement. Hopefully get it right rather than come to us when you've got problems. Quite an interesting observation in our concrete industrial floors booklet. The first 3 quarters is how to do it right, and the last quarter is how to fix it when it goes wrong. But viewers would use the first 3 quarters of the book rather than the last quarter. But there is information available, and we'd recommend people come and talk to us before they build problems into their floors or roads.
Thank you, Brian. Thank you very much.
Thank you.